Okay, hello everyone. Today we're going to create a cable or wire using geometry nodes. First of all, I'm going to open to the shader editor and I'm going to create two materials. One for the isolation. I'll just make it red and a bit more rough, and one for the wires that I'll turn metallic and give it a copperish color. Now that that's done, we can hop into geometry nodes, and the first thing we're going to do is create the isolation with a curve to mesh node. As a profile curve, I'm going to use a curve circle, fill the caps, and I can hook up the radius to the group input and rename it to isolation diameter. In our modifiers tab, we can control this input now. And what I want to do is I want to remove the isolation. I want to strip the wire, and that I can do with a trim curve node. I'll set it to length and get a new input to this start socket and rename it to stripped length. With this input I can control how much isolation is removed, and I want it to be the same on both sides, so I need to create an input for the other side using the curve length node. And from the length of the curve, essentially the endpoint, I'm going to subtract our stripped length value. Let me organize my notes a bit. This way I can remove isolation from both sides. I'll join these and rename this to, let's say, create isolation. Alright, next I want to create the wires that are sticking out at the end. Let me duplicate my group input. For the wires we need essentially the curves that we just trimmed away. So we're again going to trim the curve, set it to length. On the one side we can just use the strip length as an endpoint, which will give us this part, but on the other side, first hook up the geometry, we again need to use the curve length node. The endpoint should be at the end of the curve, so we just plug in the length, and the start point is exactly one stripped length away, so we can just subtract it from here, plug it in here, and we got both curves. Now, because we had one curve in the beginning, both of these segments now have the same direction. But what I want to do is I want to create a pattern with all of these wires, and I want to instance that pattern on the center of both end caps. So I'm going to reverse one of the curves. I don't know if it's the right one, but we'll find out later. Let me frame this again and call this create wire curves. Alright. What I'm going to do is join the geometry, and for now I'll just hook up one end and work on this one, and then in the end I'll duplicate all the modifications I made to this and hook up the other side as well. Now to create the pattern, I'll actually going to start with a point. Let's look at it from the top. I'll add some more layers of wire. So I'm going to join geometry. And then on these points that I'm going to create, I'll instance on points, a circle, curved circle. And those circles will resemble the individual wires in the end. Now, if we add one layer of wires around here, you probably know we're going to have 6 of them. So I can use a curve circle again with a resolution of 6, plug it in here, and we got 6 more wires. You can see they are not tangent, but we can make them tangent. First of all, create a new group input and call it wire diameter. We're plugging in the diameter into the radius, so I'm going to divide the diameter by 2 to get the radius. Now you can see it's tangent, but if we change our property here, it's not anymore. So we need to set the radius of our hexagon correctly. And since it's just the distance between 2 center points and their tangent, it is the wire diameter that we need to set for radius. Now I'm going to add 2 more layers. The first of them has 12 points. I'll hook it up, and if we increase the radius here to the point where they're tangent, you can see that there's gaps in between the outer wires and also quite big gaps in here. This we can avoid by rotating this circle using the transform geometry node, and I rotate it by 45 degrees. Now if I reduce the radius a bit up to the point where it's tangent, you can see it fits quite nicely. But we need to set the radius in relation to the wire diameter, and we can do this by setting the radius, which is essentially the distance of this vector. Now this vector consists, or we can build it up using this vector and this vector. The first one is just our wire diameter in x direction, and the second one has 2 components, an x and an y component. And since we have a uniform triangle here, this angle is 30 degrees. So we can use the sine and cosine of our wire diameter to create the second vector. Using the vector math length node, we can convert this vector to a scalar length value. This vector consists of 2 individual vectors that we're going to add together. Using the combine XYZ node, we can use the wire diameter in x direction for one of the vectors, and the other vector, as I said, sine and cosine of 30 degrees. So we are going to add a math node, set to sine. 30 degrees equals pi divided by 6 in radians, cosine. And now we just need to multiply these two with our wire diameter, like so, and like so, and plug them into the x and y components here. Now, it doesn't look correct. That's because I mixed up the sine and cosine inputs. All right. And for the last layer, we will have a resolution of 18. Plug them in here as well. And looks like we don't really need to rotate them again. But we need to find out what the radius is. Again, we can build up the radius from 2 different vectors, or in this case actually 3. It's the one we had previously, the other one we had previously, but double the distance. So we can just duplicate these two nodes, plug in the X component and the angled vector, and I'm just going to scale this angled vector by 2 because it's double the distance. And that's how we get our pattern for the wire. Now I'll remove the circle that I instanced on the points for now. Rename this to create wire pattern, and I'll hook up the geometry again so we can see something. All right. Now, what I want to do is get the starting point of this curve, and I'm going to instance our pattern on this point, align it to the curve, and then on all of these points that we just created, I'm going to instance this curve again, and this will give us all the individual center curves of all the wires. This we can do by creating a point on the starting point. The starting point we can get using the sample curves node, which will give us the position at location 0. On this position, we are going to create a point, plug this into the position, and on this point, we are going to instance points. We are going to instance our pattern. Let me just hook this up so we can see what's going on. Now I'll reduce the diameter a bit so everything's in view. We can see it's not aligned to the curve. How do we align it? We can align it to the tangent using the Euler to vector. The tangent is our vector and the rotation is our rotation on the z-axis. Already looks good. So next we will take these points, and on these points we're going to instance this curve. I'll get a rewrote and another one, plug this in here, but as we can see, something's not right here. This is because we need to realize our instances. Already looks better. Let me reduce this diameter. As you can see, this curve has been moved on the x direction. And if you look at this curve, the origin of this curve is at the origin of the object, which is at the origin of the word. And to make the instance on the right position, we need to move this curve to the origin. How can we move this curve to the origin? We need to transform it by how much? We need to transform it by the distance from the start point of the curve to 0. And this vector, vector math, we get by subtracting the position of the starting point from 0. If you plug this into the translation, everything's at the right position. Now we can join these to a frame again and rename it create wire curves. Alright, next I want to add some functionality to manipulate the wires, because usually if you solder or crimp a wire, first you twist them. How do we twist them? We need to change the position of the points of the curve in a way that it rotates around the central point or the central curve depending on the length of the curve. Sounds complicated, but oh, we don't want to set the material. We want to set the position. Now, if we look at it from the front, we have one central string of wire, and let's take this outer wire, which we want to rotate this way, and we want to do it for all of them, depending on the factor of the curve essentially. The further away from this end cap we are, the more we want to rotate it. This we can do by rotating this vector I just drew around the central wire. For this we want to use the node rotate, vector rotate, not rotate vector. We will plug this into the position, and our vector we want to rotate is of course the position vector of the points of the curve. Now, right now the curve has only 2 points, so if we rotate it, well, we need to set the other inputs first, but if you would rotate it, we wouldn't twist the wire because there's not enough detail and geometry. So I'm going to add some detail by resampling the curve using 64 points, and I'll do it for both of them. Now you can choose whatever resolution you want, but just remember what resolution you choose because you're going to need this value soon. Now, what is the center and the axis of our rotation? The center of our rotation is the position of the wire, and the position of the wire we can get by sampling the curve again and using the position. And the axis we want to rotate around is the tangent, so we're going to plug in the tangent as an axis. Now if we rotate this, nothing's happening. We have an error here. I guess we can... oh, what does it say? Instances are ignored. That means we need to realize the instances first. Like so. Now if you change the angle, you can see everything's rotating, but it looks odd. It's like all the curves are just one object. How can we avoid this? All of them are the same angle because we're looking at the starting point, right? We're just looking at this point. So what we need to do is use the index. The index is cycling through all the points on the curves, and since we set the resolution to 64, the index is going from 0 to 63. Now if we plug this into the vector and change the rotation, it already looks better, but you can see something's still wrong. Why is it? The factor of the curve goes from 0 to 1, but our index is going from 0 to 63. So I will divide the index by 63, and this way we have a factor essentially from 0 to 1. And it kind of worked, but only for one curve. Why is this? Because we have multiple curves and the index doesn't restart at 0 for each curve. It continues counting up. So for the first curve, we have an index from 0 to 63, and the second curve starts at 64 to 127. How can we avoid this? Using the modulo of 64. Nice. So this is better, but still not perfect. Oh, yeah, because we hooked up the wrong curve. See, we need to hook up the central curve. Now if you change the angle, it looks nice. It looks nice. But we want the rotation to be dependent on the distance of the curve from the starting point. Now we already have this created essentially with this node setup. So if I plug this in here, we got some twist, but we want to control it. So I'll add a multiply node in between, and with this multiply node we can control the twist. Let me just create a group input, plug this in, and I'll rename it to twist. So now we can control it in our modifier tab. I'll quickly clean up my nodes, join them, rename to twist. And get some more space. And the next functionality I want to add is essentially if you clip a wire and strip it, all the copper threads are not that smooth, that aligned, they spread out. So to make them spread out, we want to move them outwards from the center point. So if there's a center point, there's a wire, we want to move it in this direction. And this direction is the vector of this point minus this point. So we're going to use a vector math node set to subtract. Now the central point is our position of the sampled curve, and the other input should just be the position. With this vector we can set it into a set position node as an offset. Okay, we can't see anything. Because I probably just plugged them in the wrong way around. Yep. Now we have all the wires spreading out, but we want to again have 0 spread at the beginning and 1 spread at the end. So we can again use this little setup here, remove the frame, and just use it as a scale factor on the vector. Nice. I'll add a multiply node to be able to control the spread. Let's set this to 1 for now. And I'll add a group input so I can expose it to my modifier. Let's call this one spread. And here we go, we can control it. But let me remove the annotations first so we can see something. As you can see, all the wires are still perfectly aligned. We want to add some randomness to them. To add some randomness, I'll just create a new multiply node here and add a random value. Now, this completely messes up the geometry. Why? Because it is creating a random value per point on the curve. But we want a random value per spline. So all the curves on one spline have the same random value. So there's this node called capture attribute, which we can use to capture a random value for each spline, not for each point, but each spline. And if we hook this up, then we can see they're out of alignment and randomly spreading out. Now there's one more thing I want to add to this after joining these nodes and renaming it to spread. The one thing I want to add is that if you cut a cable or cut a wire, then all the ends usually are not perfectly aligned like they are now. If I remove the spread, you can see they're all in line. So I can just use a trim curve node and at the end I plug in a random value using math node, and I'll set it to subtract 1 minus the random value so that it's more intuitive, because it's 0, there's 0 randomness, and at 1 there's 1 randomness. Again, using a multiply node, I can expose this function to a modifier, and I'll just call it randomness. I'll again join these and call them randomness. And with our node setup completed, I can take care of the other side by just duplicating all of these and using the other curve that we created in the beginning, hook it up, and also hook up the pattern for the wires in the correct position. And then I just need to join these together, and we have wires on both ends. Now to create actual geometry, I'm going to use the curve to mesh node. And as a profile curve, obviously a curve circle. Here we go. I want to fill the caps, and the radius I need to set as the wire diameter, but as we're plugging in the diameter into the radius, you can see there's some overlap. So one more math node, set to divide by 2 gives us the correct scale. Now there's only 2 more things to do. That is set the material to wire for the wire and isolation for the isolation. And that's essentially our node setup done. If we look into rendered view, we can see our cable. We can control the diameter of the isolation, we can strip the cable, we can scale the wires depending on your preferences. We can control how twisted they are, at the same time how loose or tight they are, some twists, randomness on the ends, just to give us a realistic result. That's it. Thanks for watching, hope to learn something, and see you next time.